Hi dear student, I welcome you to this video. In the earlier video, that is in video 495, I tried to draw Lorentz curve from a hypothetical data, and you saw that when I changed the data, how did the shape of Lorentz curve change. In this video, I am going to show in Excel how to compute the Gini coefficient or the Gini index using Excel. So for that, again I'll use a hypothetical data in Excel, and then I'll compute the Gini coefficient or Gini index. So let me share with you the data. Here is my data. This is the data that I used previously, and I drew this Lorentz curve. This red one is the Lorentz curve, and this blue straight line is the line of perfect equality. So you can see from the legend, this blue line shows the perfect equality line, and this red curved line is a Lorentz curve. And using the same data, I'm going to calculate or compute Gini coefficient. And for Gini coefficient, first I want to measure this area below the Lorentz curve, and after that I will calculate this area A, which would be the difference between 0.5 and this area, and finally then I will divide this area by the sum of these two areas. That will give me the Gini coefficient. So first I would like to compute area under the Lorentz curve. So the formula for that is I'll use this plus this, and I'll divide this by 2, and after that I multiply this by the constant percentage of this percentage. This means that each of the 8 persons constitute 0.125% of the population out of 1, and if it is in percentage, then this will be 12.5%. So out of 1, each of these 8 persons constitute 0.125. So I'll multiply this with the 0.125. So this is this area, and after that I'll drag this down up to here, and now I will sum up all these areas. So this will give me area under this Lorentz curve. So in order to do that, I'll sum this. So this is total area under the Lorentz curve. Since the sum of this area and this area is equal to 0.5, so area A is equal to 0.5 minus this area. So this is area A. So area A, which is the area between this line of perfect equality and the Lorentz curve, that area is equal to, which I denoted by A. So area A is equal to 0.09, and this area A plus B, that is this area and this area, is equal to 0.5. Total area from here to here is equal to 1, but half of that will be equal to 0.5. That is why the area A and B is equal to 0.5, because we are not considering this area. And Gini coefficient will be equal to this divided by this. So we have this divided by this, and this give me this is the Gini coefficient. So this is 0.18. So 0.18 is close to 0 rather than 1. That is why the Lorentz curve is close to the line of perfect equality, and this shows that the inequality is not serious. So you can see there is no much difference between, there is no big difference between 1000 and 2800. There is a difference, but not, this difference is not much pronounced. So this is how we calculate. So this is Gini coefficient, and Gini index will be equal to if you take percentage of this, that will be 18 point. It's okay. This is a Gini coefficient, so it means that is 18%. So ladies and gentlemen, this is how we can compute Gini coefficient from a hypothetical data that I used for Lorentz curve, and we can directly uh, observe that Gini coefficient can be derived from Lorentz curve. So what we do, we divide this area between the line of perfect equality and Lorentz curve by the sum of this area and this area, that is A plus B, and this is exactly equal to the area A divided by area A plus area B, and that gives us this coefficient, which is a Gini coefficient. I hope this is interesting and useful for you. Ladies and gentlemen, if you haven't yet subscribed to the channel, kindly subscribe to the channel, and don't forget to click on the bell icon so that you could get notifications about my other videos that I'll upload for you. Thanks for watching this video. Kindly share various videos of this channel in various WhatsApp groups as well as with your friends, colleagues, and students, so that they can also get benefit by watching these